So again, welcome back to UK VMUG. I am honored to be asked to present. This is my 9th year in a row doing the keynote, and I don't get to do it by default. I get asked back, so I'm very glad that I get asked back. Also, before we start the day, and I know we'll do this all at the end, but most of you will have buggered off by then anyway, so let's do it now. This thing's run and organized by volunteers. Okay, people don't get paid to do this. People actually come here and help out their own spare time. Some of them contractors take days off where they don't get paid to come and do this. So can I have a round of applause, please, for everyone who's involved in running this? Cool. Because this isn't a VMware event, this is a community VMUG event that they asked me nicely to present at. So I've stood up here over the years and ranted about many things, and I think actually next year on the 10th year, if I am invited back, I may do some kind of retrospective. There'll be a lot of chickens in it, I think. But I thought today I'd do something slightly different, because no doubt by now, like me, you're probably very bored of hearing about Kubernetes and Tanzu and Project Pacific and everything else. And if you aren't, there's lots of sessions on that today, so go catch up. I thought I'd let you a little bit into the depths of my mind, which is a really, really scary place to be, and some of what else is going on in terms of the office of the CTO and what we're thinking about. So what goes on outside of us just working out what happens next with Kubernetes. So I thought I'd sort of talk a little bit about this evolving technological landscape and talk in a little bit more depth about a topic that is very close to my heart at the moment, something that I'm spending a lot of time working on, researching and working out how it's going to affect us as a species and a race, which is quite interesting. So looking at this, there's a couple of things that we kind of take as things that we all accept are going on. The first of those is transformation is a constant. Now, I love this because people go, oh, the only thing that's a constant is change. It's like one of the worst ever, cliches you can hear in IT is, oh, it's always changing, it's always changing. But it amazes me that I still meet people in this industry that don't like change. Usually they work in networking or storage. Oh, I've done it this way for 30 years. Why am I going to do it differently? It's like you're in IT. You join this because it's the most exciting, fast-moving industry you can be in the world and the planet right now. Nothing changes faster than our industry. Why on earth do you think, oh, I don't like change. I quite like sitting in my cubicle and pressing this button every day to run that script. It worries me that people don't do that. So change is happening all the time in our industry. And that then stuns me because people still now try and do IT projects with 3-year plans. Who's ever started a project in their life with a 3-year plan, and at the end of the 3 years, it looked exactly the same as when you started 3 years ago? Like what you planned actually happened. Because it never happened, so why are we still doing that? So I suppose my point with this slide is, stop building for stuff that's not going to change, and start building for stuff that constantly changes. And that's kind of one of the rubs we have architecturally now in our industry, right? Is we have this world of infrastructure that's always built around reliability and stability and, doesn't change and all this kind of stuff, and yet you've got people up here at the top moving literally at the speed of light trying to change things, and that's where all these clashes are coming in the middle and the fight around Kubernetes and everything else. So if we all start thinking about the fact we're going to build for something that constantly changes, we might actually get somewhere better together. And that's one of the things we're looking at. One of the things I love, if you've not seen it, is the Rugged Manifesto. Has anyone seen that? Great, right. Google the Rugged Manifesto later when I'm not talking and on a Wi-Fi that actually works. Have a look. There's a brilliant line in that which essentially says, I accept the fact that my software is going to be used for much longer than intended and for ways that I never expected it to be used for. Okay, and it's kind of understanding that. So it's a great thing. It sort of goes in line with the Agile Manifesto, so the Rugged Manifesto is fun. This I'm going to talk about in a little bit more detail. Intelligence is increasing everywhere and in everything. It depends how you define intelligence, and I'm going to talk a lot about that today. But we have to understand that now we're having decisions made in lots of places that aren't the data center. And we have to build for that too. Data's being collected in places that aren't the data center. It's not being sent back to the data center. Decisions are being made on it nowhere near data centers, nowhere near clouds. And we need to start understanding and architecting for that. Cloud is no longer a place. It never was. Please, God. Okay? It's an operating model, but it's more than that. And we'll talk about that a bit later on too. So if anyone ever says to you again, we're migrating to the cloud, you have my full permission to punch them in the face. Okay? All right. I'm not going to cover you for any legal costs or anything, but literally, if you post it on Twitter, I might retweet it. That's what I'll promise, okay? But literally, it's not somewhere where you go. I think we finally worked that out now, okay? It's certainly not somewhere where you put everything either. This is an interesting one and sort of drives how we look at some of the stuff we do. Differentiating innovation supersedes incremental innovation. Yeah, I present this in countries where English isn't the first language. Can you believe that? And I can't even say it or even understand it. What we're trying to say here, and I suppose what I'm trying to understand in this one, is the fact that the bigger leaps are made by stuff that actually innovate things that makes them different from someone else, not just what makes the next obvious thing to do with my technology. You know, next obvious thing to do with my technology might be make it a bit faster, make it scale a bit better, when in fact the differentiating thing from all the other technologies might be do something in a completely different way that delivers a service in a different way. So when was the last time you innovated and thought, oh, I'll just make it a bit quicker, a bit faster, you know, a bit bigger or whatever? Sometimes you have to make radical sidesteps in industries to do that. Maybe not quite as radical as the Cybertruck, but you do have to make radical sidesteps to change industries. Autonomous, this is from one of our colleagues in the Octo, and I leave it in here because it's always a great source of conversation between me, him, and a few others, is that autonomous delivery breaks traditional IT assumptions. What that means is, if I can get you a new piece of kit delivered to where the broken piece of kit is in under 4 hours by a drone, how does that affect your architecture? How does that affect how you build stuff? If I can get Amazon, not just done by a drone, if I can just get someone from Amazon to deliver a brand new widget to that retail site within 4 hours and the person plugs it in, how does that change how you design things? Why do we build things differently in a world where actually we take advantage of the infrastructure that's there to support us? Pragmatic DevOps is a term that I'm starting to like using. And this is what we mean. By this we mean where developers and operations teams can find common grounds in the best of both worlds, which is really what DevOps is all about. Okay, it's about developers and operations teams moving and working together. So I think it's much more about. I think pragmatic DevOps means let's lose the religion about all this crap and just get stuff done. And where I'm seeing DevOps and those kind of things, and people move forward in that world of the friction between the fast-moving and the arguably slower-moving lower layers, is where people pragmatically look at what they think they should be doing. And as an example here, we sort of talk about give developers the experience they require, which is more often than not just including native tools and APIs while allowing operations tools to use the tools that they want. And to be essence, that's what we're doing with Project Pacific, and that's what we're doing with our Kubernetes toolsets, is trying to do that. And as we go forward over time, as we start to bring more and more of vCenter to be in Kubernetes, is actually what we're going to do, you'll see more and more that what we're doing is making that a little bit easier for people. But this is the kicker. If I think back to one of my previous presentations in the Motorcycle Museum, when I stood there and I talked about, this is before vRealize, right? This is before, and I told everyone, you're all going to be automated, but you're not going to be out of jobs, but you better learn how to automate, otherwise you're not going to be in a job, right? Which is true, okay? We've now got to the point where automation is no longer some kind of optimization you do afterwards. It's a design requirement. You have to build it in from the start. You design infrastructure to be automated. That's a different mindset, right? Rather than looking at infrastructure then working out how to automate it, this is how do I build and design infrastructure so that it can be automated from the start? And more importantly, design and build it so that it will be automated. That starts to make us think very, very differently about how we deliver stuff. Citizen developers. This is a fun topic for me because we talk at the moment about developers being these sort of, cool guys wearing hoodies, sat in the corner, usually with beards, etc., doing coding and stuff that most of us don't understand because we don't do coding, apart from, the odd bit of scripting now and again. The developers of the future won't be those guys or those girls sat in the corner in their hoodies. The developers of the future will be everyone. As we start to build more and more ways for people to build and customize their own experience of computing, more ways for them to do that than they do today. We all do it today. You're all citizen developers because we all have Excel spreadsheets, which is how you run most companies, right? I love it that I go to a company and they talk about our system of record and how we run our businesses on Salesforce. And I go, okay, fine. If I go and grab any one of your sales managers right now, can you promise me they don't have their own personal spreadsheet in Excel that actually tells them what's going on in their business? because that's how they do it, right? And that's going to evolve. So more and more and more as we go forward, we need to be preparing for this world of citizen developers. So that's what we're looking at too, is how do we enable people to build their own apps without realizing they're developers, which I think is actually what you're looking at here, because people build their own apps in Excel all the time without realizing they're developers. Thank God, finally, in most places, apart from a few dodgy banks and a lot of local government, access is finally dead, okay? But we're getting to that point with Excel and other things too. So we have to understand how do we, in building these automated platforms with these tools for developers, how do we then expose those tools to be tools for everyone to be able to use? And how do they then get to build their apps? So we have our NASCAR slide or buzzword bingo slide, or every CTO has one slide, of emerging technologies. And this is evolving constantly. In fact, there is a thread going on right now between myself and some other people in this room and others about what should be on and off this slide. And there's things I don't agree with, like I don't like calling it a self-driving data center. I think it should be called an intelligent automated data center, because as anyone's tried a self-driving car, crap, I wouldn't want my data center run like that. Okay? But we're looking at things like data analytics. We're looking at hardware acceleration. You'll hear a lot more talk about that. You've seen our recent acquisition of Bitfusion, what we're doing with GPU acceleration and virtualized GPUs. Specific hardware, job-specific hardware is becoming more and more part of what we're discussing with our customers, specifically GPUs at the moment, but also FPGAs and all those kind of things as well. So for us, understanding those technologies and understanding how we can play with those and integrate those led to the acquisition of Bitfusion and things like that we're doing. Of course, there's serverless, or FAS, and we'll talk a little bit about that a bit later on. There's the building in of intrinsic security. How do we stop bolting security on? How do we make it part of the design requirements? Of course, there's Internet of Things. Why could you not have a slide today without Internet of Things on it as a CTO? No one knows what it is, but it's really cool to talk about. Zero trust computing. Now, we've been talking about zero trust for a long time, but now again, of course, because obviously some analysts somewhere at a conference used the term, of course, now everyone's talking about it. So zero trust computing is becoming an increasing theme with our customers as they start to realize how they're going to build and enable those citizen developers, how they're going to deliver applications to any device, and the fact they finally have to realize they're not going to manage every device. Telco and 5G, what a lot of people don't realize is one of the major divisions, in fact, the only division that's focused vertically upon one particular industry at VMware is our telco division that specifically has solutions around 5G. If you've made a phone call on Vodafone, actually, not on 5G, just on Vodafone full stop some point somewhere in Europe in the last year, that's gone through a VMware hypervisor at some point. So that's pretty cool, okay? And in fact, the 5G rollouts that are happening in the UK, most, if not all of them, are underpinned on a VMware cloud to actually run those 5G functions. And in there, we're introducing technologies such as network slicing and other things that are going to truly transform how we deliver things in that space. Of course, you've got multi-cloud computing and hybrid cloud computing, which I can bore you with forever. Smart electrical grid, which is something that I'm very personally interested in and playing about with. I know there's a couple of people here also interested in doing that, even if it is just hacking the batteries in their house. The smart electrical grid is important for us as a company too, as we start to build out our own smart grid at our facilities in Palo Alto and become entirely self-sufficient there. Augmented reality, beyond just being an excuse for Al Renouf to play with some goggles, is actually an investment by us in some specific projects around some specific use cases for our customers, but that ties together with IoT, it ties together with 5G, it ties together with network slicing, it ties together with edge computing, and all those other different things, because I don't know if you've realized, but if anyone's ever tried augmented reality, can you imagine if I turned my head and then had to wait a second and a half for it to talk to the cloud and back to keep the picture updated? You'd vomit pretty fast. So you need low latency networking, you need high-speed processing and compute decision-making locally. So there's a whole lot more behind that than just some cool, funky goggles that talk specifically to application architecture and architecture design. Blockchain. No, blockchain's really, no, it's not. For interesting stuff, we've been running blockchain projects for a while. We've had blockchain research projects going for a long time. Blockchain is massively overhyped in pretty much every possible way. I've got one of my colleagues down here who's from the banking industry who literally physically convulses when you mention the word. But we have done some severely interesting work because we've solved some of the problems with blockchain in terms of scalability, in terms of resilience, etc. Specifically in an open source project called Hot Stuff that should have been in the quiz last night. I didn't name that. I don't know who did, but that's actually the core technology that's now been adopted by Facebook for their currency. So it's kind of cool that, you know, stuff that we've developed at VMware is being used for that. And it's being used now to run a particular stock exchange. And it's being used in lots of interesting places, you'll see. So we are developing technology there that will underpin some interesting things going forwards. And of course, quantum computing. So there's some, I could do 45 minutes of hand waving, but yeah, you know, quantum computing. We're looking at it. Again, the main thing there is there's this huge fear, quite well founded, that you could write a reduced function on a quantum computing that could crack all known forms of encryption in fractions of a second, thereby rendering the entirety of the world and the internet useless. It's like something out of Star Trek, I think, or something like that, or Black Mirror. Or what we're actually working on there is we're not doing quantum computing research. We're not building huge, great, funny things in hyper-cooled data centers. What we're actually doing is we're looking at the algorithmic side of that and how we can build and help with the research on quantum-proof encryption. And because that's kind of at the core of a lot of what we do and how the internet works. But what I want to talk about in a little bit more detail today is this one. I want to come back to automation is no longer an optimization, and it's a design requirement. Because that leads me into one of the core topics I'm looking at the moment, which is one of the ultimate cool buzzwords in the industry right now. And I'll explain why, as you go through this, why we're looking at this at VMware, which is AI. And before you all groan, okay, the problem we have with AI is it's worse than IoT in terms of public perception, mainly because my mum's heard of it, okay? That's part of the problem. And when you mention AI in the real world, what you find is they start to talk about stuff like this, and they think that AI is all about, you know, Terminator and all those kind of wonderful, scary outcomes. They tend to associate it with robotics, which is not really where AI is today. Of course, they do also, the real hardcore people, associate it with this. Those of you in the audience will know that's Blade Runner. We are in Blade Runner month. I don't know if you know, but Blade Runner actually was set opening in November 2019, so we're here. The closest we've got to Blade Runner so far is oh shit, no, not that one. Is this, which surprisingly looks like that, which is from the movie, if you remember. See, there's similarities there. But for those of us hardcore gamers from about 20 years ago, I think it looks more like that. And those of you who played with Warthog physics will remember that. So I think I'm going to get one just so I can make it out and look like a warthog. But actually, when we come back to AI, you get back to now we're at the existential point where people are arguing about Asimov's laws of robotics, which hopefully you should all know, because if you don't know them, you're in the wrong room, okay, basically. So we all talk futuristically and wonderfully about AI, and we all seem to focus on robots, when in fact, when I talk to my mother about robots, this is what she thinks robots are. And to be fair, that's about as close as most people in our lives get to something that maybe they think is AI or robots, apart from a couple of other different things. I've always been intrigued by these, actually. I've always wanted to actually go in with a live squirrel, mainly so I can truly have a proper unexpected item in a bagging area. But we'll see. So, but this is an interesting point, because these are the robots that are taking jobs. If you talk to the press, and if you go and talk to the BBC, as I get told to do now and again, the conversations I have on BBC World News are how robots are taking away jobs. And actually, it is that interesting balance between robots and AI, and how robots and AI are going to take over people's jobs, which is where most people have their fear. Okay, some people look at the Boston Dynamics stuff and just literally crap themselves about what would happen if I put weapons on that, which is surprisingly what Boston Robotics is doing it for, but you didn't realize that. But more importantly, most people look at these things and get worried about the future of their security of their job and what's going to happen. And it's interesting because we've always been replacing jobs with technology. It's happened forever. Some of you may remember fondly the knocker-uppers of the past, which was an official job. I don't know if you know a knocker-upper, which was someone with a long stick that used to go around in the early morning and bang on people's windows to wake them up before the invention of alarm clocks. It was a real job. The night soil man We all long lament the passing of the night saw man, who was the man that used to go around and collect the stuff that you used to leave in a pot at night time before we had sewers, and after we'd accepted that throwing it out the window into the street was not normal. Gas lamp lighters. Do you see my point? These things come and go. The problem is they came and go at a generational speed. Now they're coming and going within decades, within years, within months. That's why people are panicking about it. So when you actually get to thinking about it and spending long times thinking about it, you realize, as I have done, that artificial intelligence is actually less about the machine and it's more about the human. And it's about our relationship with them that's really important for us to contemplate when we look at AI going forwards. So you have to think really deeply about the past to look into where we're going in the future when it looks to AI. So if you go way back into ancient tribes, before any real technology as we know it today, or even thousands of years ago, realistically, back in these days, humans competed on muscle, and muscle alone. And so it tended to be the fittest, the strongest, that won. The guy that ended up, and it was always a guy in most cases, that ended up in charge of the tribe, was the biggest, strongest bloke. And because men were traditionally bigger than women, that's just how it happened, that you ended up with this society where you had the biggest, strongest bloke who was best at beating other people up. It's kind of like school, became in charge. And then other people who weren't quite as big, but were bigger than other people, then gathered around them and formed their little cohort of friends, and that became, you know, the center of power was the big bully boys. But in essence, that's how tribal existence worked for years and years and years and years and years, until we looked at ways that we could augment our muscles. And one of the ways we learned very early on as humans to augment our muscles was through the use of animals. And there what you're doing is you're using their muscles instead. And no, we started to use them both for war and for work. You rode horses to go and fight on, or elephants, or anything else that looked big and scary to people. And you also use them to go and plow the fields. And so now we started to do something which is fundamental to this point I'm making. We augmented our lack of human ability with technology. And in this case, we augmented the lack of human muscle with animal muscle. We could ride faster, plow more fields, do all manner of more things because we used animals' energy to do that. And this gets to the point. It's about energy conversion. We literally couldn't convert energy into power fast enough in our own muscles, so we had to find other things that were converting energy into power at a greater rate or at a stronger rate by using muscles. Then technology comes along, and there's an explosion of technology. And we start to discover how to harness and use differing forms of energy to do things in ways that we'd not imagined before. But we were still, in essence, augmenting human muscle, replacing what 500 humans would do with one machine, for example. It was still muscle that you were replacing at this point, whether it was with electricity and engines and electricity that were driven by electric motors, or steam. We were still augmenting this, okay? The real breakthrough came through, and this is thousands of years, but all we're doing is just doing faster, bigger things, replacing human muscle. And so now what you've got is the people who were in charge were the people who could command thousands of machines. Then the industrial age came along. And now industrialists, who were the people that were the most intelligent of how to organize machines, how to arrange machines, became the ones with powers. They weren't necessarily particularly strong physically themselves. I mean, look at Eisenberg and Brunel. He wasn't very big, right? But they were the powerhouses of their time because they understood how to harness that energy and make the most of it. So still they were competing on muscle, but then they started to compete on brain power, okay? And so now we're competing on brain power. We've moved our competition from here to here, because I can augment these as much as I like just by buying bigger and more machines. Then we come to this. This is a IBM 1401 mainframe. This actually is in the Computer Science Museum in Mountain View in California, which actually Robbie and myself and a few others went to go and see it, because we're that boring that when we go to California, we go look around computer science museums. But this was the first this was part of the series of the first programmable computers, System 36, 1401, etc., where people could start to augment something else now. I've augmented my muscle, but now I'm going to start augmenting my mind. And so now we're in this age where we're now not only be able to compete by being the most clever, I can be more clever than you, I can be faster than you, I can be better than you. My mind can be augmented. And that's where we are now. This age that we're in is where we've gone past muscle augmentation and energy augmentation to thinking augmentation and mind augmentation. And so finally you get to this sort of goal we have of AI, where we go, okay, well, I want to have the ultimate machine. I want to be able to make decisions faster than anyone else. I want to be the most enlightened. I want to be the most augmented. And so if you look at it not as how do we replace human thinking, because that's not typically what we've been doing. Yes, certain sections of society and individuals have been replaced by certain technologies as we've gone forward, but we've all evolved. We've all evolved, actually, to a world that's much better, arguably, apart from the fact we've completely, excuse my French, fucked up the environment. If we ignore that piece, in terms of how we live today, we're generally healthier. We have more free time, if you put your phone down. You know, we do less physical work. Generally, humans have improved as a race. So what's next? Well, the interesting one for me when I think about this is you think about, well, if I come to the ultimate augmented human in terms of augmenting their mind, which we all are today because we're all augmented with this device in your hand, this phone, right? That augments you as a human. We're all slightly robotic. I mean, I do remember when I was at school, you probably do, doing those exams, and the teacher would say, well, you're not always going to have a calculator. You need to learn how to do it in your head. And I'm kind of like, yes, I do have a calculator all the time now, even on the toilet. Right? I'd love to go back to Mr. Memory, wherever he is now, who was my maths teacher at school, and wave my mobile phone at him. He'd probably still throw a board rubber at me. But we are augmenting ourselves already with technology. So now we're seeing where do you compete next? Because humans have competed on muscle. We've discussed that, right? We've competed on muscle for years and years and years. Now we're competing on brain power. Putin talking about the country that has the best AI will be the most powerful country in the world. And already we're starting to see how they're making the most of doing things like that in Russia and other countries. So if we're no longer competing on minds, what is there left to compete on in the human consciousness, in the human endeavor? And the answer to that is arts and hearts, or my answer to that is arts and hearts. I seriously think we've moved from competing to here. We've now got to the point where we don't have to compete here because we can augment our brains to do any information anywhere at any time. It's now down to how do you compete here? How do we actually differentiate ourselves from others through how we think and feel? And that's an interesting one, because that's what we're struggling with in AI right now, is we can get AI to do some interesting and wonderful things, as I'll talk about in a minute, but we're really struggling with anything to do with arts, with emotion. You know, think about it. We spent thousands of years trying to define love. Do you think we're going to teach a computer that in 1 year, 5 years, 10 years? These things are very difficult to quantify, even for us. So how we augment and do that going forward is going to be an interesting one. But you're already seeing it today. You are now choosing companies not just because they're the cheapest, or they deliver stuff to you the fastest. You're choosing companies because of the service level they give, right? You're starting to go back to those companies where you can pick up the phone and talk to a real human being because service differentiates, because that feeling is there for you. And I think the ultimate evolution of this you see in Star Trek. Because when I think about how I want healthcare to be going forwards, when I go and see my doctor, and we all learn this as you get to sort of, I found it's sort of like mid-30s, I suppose, really, is when you discover that doctors aren't very clever. And you got to that point and you go, shit, they're about the same as me, really. It's just, you know, they've been studying humans as long as I've been studying computers, and crap, I'm bad at that. So how do they know us, right? That's kind of the realization I have, which is scary. But there's a problem with that, because at the moment, there's about 3,000 oncology papers published, peer-reviewed a year. Now, oncology is the study of cancer, some of you may know. So if you go and see a cancer specialist about that cancer problem you've got, there are 3,000 papers on cancer that have been published in the last year. Do you think that specialist has read all 3,000 of those? That's roughly 10 a day. And if you think they take about an hour each to read and interest and just inwardly digest, that's 10 hours a day this guy's got to spend, or this woman's got to spend, studying these oncology papers just to keep up to speed. All right? Even if they read them just every time they go to the toilet, it's not enough. Okay? So what you're looking at here is what I want to be diagnosed by a computer, but we're still going to want a human to hold your hand. When you go to that hospital, you're going to want Scotty there with the, not Scotty, why do I always say Scotty? Bones there, right? Scotty, good God, sorry, apologize. I'm really a Star Wars guy. You got Bones there with the scanner, the medical scanner that he has. That's your AI, that's your I know everything that's going on. But he's still the guy there deciding on the medical pathways, helping you understand what's going on, that human touch. And I think that's going to continue. I really, really do. And that's what I talk about augmented humans. Because doctors can spend more time doing the stuff that matters and engaging with patients. When I talk about job replacement, is a good one is restaurants. Because actually, the things that are going to be replaced by AI are not the shop assistants. It's not the waitresses. The things that are going to be replaced by AI is middle management. And I'm not saying that in some kind of, weird hatred. It's just a reality, okay? Because if you think about what middle management is, it's really someone who sits there and makes some decisions based on inputs and data. That's really what they're doing. A great example is a restaurant manager, okay? Now, if you think about what a restaurant manager does, and most of us at some point in our career will have worked in a restaurant as a waiter or waitress or whatever, I certainly have, and no doubt you've all at least been in a restaurant at least once, so it's got a frame of reference for everyone. A restaurant manager, all you're actually really doing, and I've done it, is you're kind of sitting there going, okay, how many staff am I going to need this week, and how do I organize the rota? How many people do I think are going to come in, and so how much food do I need to order in? And how am I going to run and organize this all during the day and deal with anything that comes up? So what you now find is most of the time when you go and see a restaurant manager, they actually spend most of their time in a back office in front of a computer, jiggling all this stuff around on a screen. AI will replace that. I can use AI to predict how many people are going to come into the restaurant. I can use AI to do the ordering. I can use AI to do the rotoring. All those little stupid things that we end up making decisions on, which are the same week in, week out with a little tweak, they can be automated. Does that mean the restaurant manager loses their job? Not at all. It means the restaurant manager can spend more time out front, can spend more time actually interacting with customers, can spend more time looking at ways to improve the business, looking at ways to make things better, can spend more time on the arts and hearts. So we are going to have AI in our lives. You're just going to have to live with it. But you either accept it or you run away scared from it. Now, as you go forward in our industry, you're all going to have AI projects. Now, the thing that happens in your organization is 80% of AI projects, in reality, will end up as some kind of alchemy, right? Run by wizards whose talents just won't scale within the organization. It's going to be something special. And eventually, you're going to start buying AI in as a service anyway, so you won't have to worry about it too much. And as my boss says, Pat, the AI is the 60-year overnight success story that's kind of finally here. If you speak to Pat, he tells you a great story. He was the PM for the 286 and the 486 and the 386 as well, if anyone remembers those. And at one point, I think they came in and asked him and said, the 486 has got to be the best chip in the world for AI. This is in the 80s. What did they even mean back then? I don't think they did anything. They just said, yes, it is, and moved on. That was fine. But finally, we're there. Deep learning and machine learning are actually becoming a reality, and I'll talk about why in a second. But how they're manifesting themselves is very different. They're manifesting themselves in what we call task-specific AI. There's two types of AI that people look for. One's called AGI, which is artificial general intelligence. That's your iRobot. That's you're trying to replace an entire human brain. That's AGI. Someone looking for something that they can interact with. That's your HALs. That's all those other kind of things. We are still miles away from that. Where we're close on is task-specific AI. And that's this. Now, the thing is that people, because you interact with this with a voice, and it replies to you with the voice, People think they're talking to an AGI. They think they're talking to an artificial general intelligence. They think they're talking to something that is a human being just down the other end of a phone. But in fact, if any of you have ever had one of these devices and played with it for more than 10 minutes, you'll realize it is a million miles from any form of AGI. Honestly, the Google one is better than the Amazon one right now, mainly because their NLP stuff's pretty cool and how they're actually working with it, but they're fighting constantly as to which one's the best. So most people are seeing AI in their world, they think it's this, which this really isn't, to be honest. There's not a lot of AI going on in this at all. There's a little bit of ML in terms of the speech processing. It's mainly a whole bunch of scripted responses. The other thing where people see AI is this. They think this is AI as well, because mainly people tell them that it's AI. It is to an extent, and this is where it gets a bit more interesting. And in fact, self-driving cars is a really good way of explaining the difference between machine learning and AI, for those of you who have not studied it. I recommended this to someone last night, actually. If you really want to learn a little bit more about AI and ML and some sort of deep neural networks and how they work, there's an app called Brilliant, which I know is available for iOS. I think it's available for Android. Has some fantastic free courses on it. And the one on deep neural networks is brilliant because it teaches you about how they work and how they're built up. And then there's one on regressive learning and all this kind of stuff. It's great. So it's a really good introduction, as opposed to if you go to one of the normal sessions on AI, they dive straight into some weird stuff about TensorFlow, and you're lost in about 8 seconds and don't know what they're talking about. Right? So if you want that grounding, the kind of stuff you'd get on a university course, that's what I'd recommend. So this is a great idea, a great example of how to define the difference between ML and AI, because there is no machine learning that goes on in the car. There's AI that goes on in the car. What happens is the car is continually recording all that stuff you see on the right that it's seeing as well out there in the real world, and it's sending that back, along with how people deal with things, how people react, where people make corrections, where people take over from the self-driving car. That all goes back to a big central computer, which may or may not run on VMware, that sits there and runs through a huge machine learning algorithm to better educate an AI model. So it takes input from millions of miles of driving, creates a new AI model. It then pushes that AI model back out to all the cars. And the cars then use the AI model to take inference from the inputs that it's seeing and make decisions based on the AI model. So yes, the car is using artificial intelligence. It's looking and working out, that's a car, that's a dog, that's a bicycle. Interesting, if you watch the video from one of the Tesla things, they had a real session with trying to work out a bicycle strapped to the back of a car being different to a bicycle on a road, because obviously you have to work out these things. But the AI execution is going on right there in the car. The ML is happening somewhere else. So AI and ML are often conflated. They're not. They're very different things. And in fact, if you look at the taxonomy of AI, you're looking across most of what people call AI is a bit like the Princess Bride, okay? And you all know what I mean by that. If you don't, go look it up. Inconceivable. Now, a lot of what you'll hear people call AI is what traditionally we call data analytics. Okay? A lot of what people call machine learning is just data analytics. It's basic stuff that we've all done for years. It's only when you start to get with machine learning driving deep learning, building neural nets with weighting and probabilities, etc., that actually are starting to make decisions based on inputs as opposed to coded systems analysis or data analytics, do you start to get what the industry would start to call AI. And then you get over to the world of artificial intelligence. So AI really is intelligence demonstrated by machines. It's where machines are starting to make decisions based or take inference based on the inputs. So why am I talking about ML now, and why is the industry talking about ML all of a sudden? I mean, if it's been around for 60 years, why is it so important? Why are we all looking at it? Well, simply, we have more data than ever before. ML requires an awful lot of data. Those of you who've had kids will know that if you've got a 4-year-old child, you can show them about 5 or 6 pictures of a dog, and show them about 5 or 6 pictures of cats, and then show them a picture of either a dog or a cat, and they'll pretty much be able to tell you whether it's a dog or a cat from the 12 inputs they've had, okay? With a computer, you need to multiply those numbers by about 1 million to get anywhere near it starting to be able to tell you whether it's a dog or a cat. You need to show it 1 million pictures or 5 million pictures of dogs and 5 million pictures of cats for it to even start to think to know what a cat is. And we actually included some of that in the keynote this year at VMworld in day 2. Some of you remember with the lovely pictures of I think, golden retrievers we used. So there is more data. Why is there more data? Because you guys are just generating it all. Uploading it, pictures, Facebook. Better than that, you're actually helping and educating AI right now. Capture. So some of you remember Capture from a few years ago. Now, Capture a few years ago, which was actually invented by the guy who went on to create Duolingo, by the way, which is also interesting. But Capture was invented, and what we did with Capture, really, as an industry, was we translated books. We transcribed books. So you were presented with some funny characters and asked, what do these characters say? And typically, do you remember those ones we used to get two? Some were computer-generated, and one was obviously a picture of some letters. The computer-generated one, we knew what those characters were. The letters one, we had no idea what they were. But if we asked enough people on the internet what they thought they were, you were eventually teaching computer AI how to read books. So through Capture, through millions of people with billions of entries, taught us how to read books with computers. That's exactly what we did. So guess what you're being asked now, guys? Has anyone had those ones with click each picture that has a car in it? What do you think you're doing there? Click each picture that has a palm tree. Click each picture that has a bus, right? That's what you're doing now. That data, you're actually educating and teaching machine learning algorithms for self-driving cars and computer vision, but you didn't know it. Cool, huh? So there's more data being collected. We have more computing infrastructure. We have these distributed training platforms. We have hardware accelerators specifically built for ML. Both NVIDIA doing that, many others doing that. Tesla have actually built their own that they're now doing, that they're putting into their cars. It's getting quite cool. There's better models and learning algorithms. There's cool things you can buy. Has anyone seen the little, there's a DJI, Tello, it's called, which is a very, very tiny little thing. That's actually got a small ML chip in it that will do basic image recognition, and you can start to program a drone to recognize your hand and stuff for $99 or 99 quid. Very, very cool. And there's a whole bunch of frameworks you'll see up here that are all open source that allow you to go and play with this. So you can pretty much pick up and play with AI and more especially machine learning today. And I strongly recommend you do. It's an interesting thing just to go play with. Have some fun with, get a bit of an understanding about it. So when it does start to pop up in your day job, you've got a better understanding of how it's going to work and how you can, more importantly, game it for your advantage. Sorry, did I say that out loud? So let's talk about gaming it for an advantage. So this is a good one. So this is, ML is not intelligence, and this is really important. So up here on the left, I've got some pictures, and this is how you trick ML. So that's a picture of a dog. We're pretty good at that, right? You've all been well trained with your AI models in your head that that's a dog. If we add that much computer noise on it, which when overlaid on top of that picture, the picture to a human still looks the same, but to a computer, the model that that was looking at now thinks it's an ostrich, based just on some noise that I overlay on the picture in terms of the pixels, because they know how to game the model. This is a great one. So that's, I keep forgetting her name, Reese Witherspoon. If you then put a pair of glasses on her with a weird pattern on them, the computer thinks it's Russell Crowe. Right? And there's loads, and you can actually do that in real life with printed glasses. You can trick these systems. It's happening more and more. I don't know if you saw recently, I think it was in one of the New Scientist or whatever, there was a good one where there's a researcher there has started to actually print both glasses and look at weird face masks or ways you can use face paint to completely trick all facial recognition systems as well. So if you don't want to be tracked by the public and by the government, et cetera, that's happening too. And this is because of a very small problem that's actually probably the biggest problem we've got in AI today, which is explainability. With machine learning, what you're looking at there is we're essentially training something, but we don't know what it's trained itself to do because we can't dig into it and unpick it because it's so big, so complex, we can't see what it's learned. There's some fantastic examples of this over the years. My favorite is from many, many years ago in the early days of computer vision, where they were trying to, of course, use it for military purposes, which is where most of this stuff happens anyway, where they said they showed it lots of pictures of fields with tanks in and fields with no tanks in, right? And the idea was to create a computer vision system that could automatically find camouflaged tanks. By the end of it, they processed it all. They did all this training over a long period of time on some very old computers a few years ago. And at the end of it, what they'd actually ended up doing was training the computer to learn the difference between a sunny day and a cloudy day, because most of the pictures of tanks were taken on a sunny day. But they didn't know that till they started to test the outputs. It's like, oh, okay, that's not good. There was a good one where they got a computer to play Game of Life. Remember that Game of Life, the little computer game with the little things? And they wrote a slightly more complicated version of Game of Life. And the computer started eating its own babies, because they'd set the parameters wrong on the model, and basically you got free energy if you had a baby and ate it, because the energy, it was great. And so they created an entire society that was basically just having babies and eating them. There's a famous one with Facebook, Bob and Alice, where they introduced chatbots, and a lot of you will have heard of Bob and Alice, where Bob and Alice actually invented their own language to talk to each other so the humans wouldn't know what they were talking about. So we don't know what we're doing with a lot of these systems. And that's not to scare you, but it's actually an area of research for us right now at VMware, is how do we can understand and build explainability. The law also has a lot to learn. And this is really interesting, because there is no differentiation in IP law right now between a trained and an untrained system. So if I take a brand new empty ML model, and then I come to your company, and I ingest all your data, and train my model using your data, and then walk away, from an IP perspective, I have nothing, which is really interesting. And the best way to explain that is like if I go to university and learn to speak Chinese, does the university own the Chinese that's in my head? No, because that's mine because I learned it. So there's some really interesting stuff about where your data, when ingested into an AI model or an ML model, what the legal cover around that is. Microsoft, as was in the quiz last night, actually, which is why I knew the answer, deleted in June this year a big facial recognition database, but which is stupid because everyone's using it and everyone's got copies of it anyway, but it had 100,000 celebrity faces in it as well, which is why they got upset. And again, these are all being trained into systems, and people got upset that their faces are being used to train into systems. And there's a whole separate topic, which I'm not going to go into, about bias in AI, which is, if you want to really go down a nasty, horrible rat hole right now, bias in AI is one of the worst ones that there is, because most of the training models that are used to train facial recognition are not exactly very, shall we say, balanced in terms of the faces that are in them. Which leads me nicely onto chemistry. I have no way how to segue this, right? I thought about it for years, so I just thought I'm just going to go, which leads me nicely into chemistry. And it worked. None of you went, what? Well, you probably still are now. So why am I talking about AI? Why is VMware looking at AI? Why are we researching all this kind of stuff? Why are we looking at ML? What's the point? Why is it just because it's cool and fun and interesting and we're paying you guys too much money and you've got too much spare time? Definitely don't have that, spare time or money. No. It's because of what's happening with apps. That's why we're looking at ML. It's because of what's happening with apps. That's why we're looking at AI. So what we're looking at the moment is this chromatography of applications. Now, some of you remember your high school or whatever it is, chemistry, where you did this chromatography, where you got a liquid, you dropped it on a piece of paper. This, in this case, is ink, blue, brown, red, green, burgundy, and orange. I think it's burgundy. Can't think of any other. You'd use BU. And then over time, that ink spreads itself out into its constituent parts. And you get to see which bits make that up. But more importantly, those bits of that application, okay, are finding the best place on that paper to exist. That's exactly what we're looking at now. When I say cloud's not a destination, it's more of an operating model or a business model. That's because no one of IaaS, PaaS, or SaaS is going to be the answer to your application future. In fact, it's not just IaaS, PaaS, and SaaS anymore, because we've now got CAS, FAS as well. So you've got computers as containers as a service and functions as a service. So you've got infrastructure, containers, platform, functions, software as a service, all these options. Now, the great thing is you'll go to conferences now. The serverless ones are my favorite, where they'll tell you that if you're not doing everything in serverless, you're some kind of backwards-looking, old-fashioned boomer retard. Is the best way to describe it, okay? The simple answer is no one of these is the answer to everything for your application. Oh yeah, the decision isn't 5, by the way, it's 10, because you've got to choose whether you're doing them on-premises or off-premises. Okay? So whether you're on-premises, the titles are messed up here, but it's on-premises on the left and off-premises on the right, or the other way around. Doesn't really matter. Okay? What you're looking at here again is that actually you're going to get your applications right now. You know that lovely 3-tier app that you've cosseted and loved for many years that runs on that nice little SQL server or that Oracle database with a piece of WebSphere or WebLogic on top of it, and it's quite nice. You did a bit of sharding a couple of years ago. Oh, edgy. And now someone says, we want you to put that in the cloud, and you're looking at this and going, well, which bit of the cloud do I put it in? Well, you could drag and drop it into IaaS. Our VMware Cloud and AWS friends would love you for that. But actually, what you're probably going to do over time is deconstruct that application. And some of it's going to be done in SaaS, some of it's going to be done in IaaS, some of it's going to be done in PaaS. You're going to do some bits in containers. You're going to use a service from Azure to do that over there. And your future applications are going to be incredibly distributed. There's an example that I've used many, many times. I'll continue to use it. Of a factory making cars, and what they're doing is they're using IoT edge gateways to track what's going on in the factory. So that's using serverless on the IoT edge gateway. So that's up there, that's on-premises FAS, to then write down to an on-premises SQL database what's going on in the factory, where the cars are, how many tires I've got, how many doors I've got, how many front subframes I've got, which is a personal problem right now. And so on and so forth as they go through the factory, and that's written down to a SQL database. But of course, they've then written some sexy stuff in containers. So up here in containers as a service. So we go from there, from function service, writes down to IaaS. They then have some container stuff that extracts that out here to Amazon, puts it on S3, where they've then written something really funky in Cloud Foundry that then provides a nice dashboard for their management. That's a typical application. It's not special. It's not, oh, wow, you're doing something new and funky. That's normal now for how people build new apps. In fact, there's some cool stuff here because they can now permission the S3, so they've got external companies connecting in now to see how many tires there are in the factory and when they need to supply more tires and ship more to the factory. So it's a much better system overall. People are getting real-time dashboards, all that kind of sexy stuff. You couldn't do that before in your WebSphere thing on SQL Server or DB2 without an awful lot of pain, hacking, arguing, you name it, right? But now it's the norm. So actually the norm is the application is a network. And that's why we're looking at ML. And that's why we're looking at AI. Because traditional management tools were great when you had traditional applications. Traditional monitoring tools were great when you had traditional 3-tier applications. When I was building stuff like Foglight and things back at Quest in the day, that was fine. Right? Because that's how apps worked. If we were being really edgy, we had an appliance that looked at some of the traffic on the network. Woo! Okay. Now, I've got components and bits of this application everywhere. I've got data that's coming into my system and being killed where it's read, because I'm not using it, right? But I still maybe need to look at that from an auditing perspective. I maybe need to monitor how that's being pulled in. So I need to monitor everything. I need to track everything. I need to optimize for a distributed system. I need to optimize for a changing distributed system that's running in multiple public clouds across multiple different public networks that are continually changing, coming up and down. No human being can do that. You all at some point in your careers, unless some of you who look really young in here probably will not get this, but you all at some point in your careers would have been able to, if I asked you, I could have got you in a room and on a whiteboard, you could have drawn me the topology of whatever it was you managed. And there would be some IP addresses on there, and there'd be some names, and you'd tell me what things did and how they all worked and how they all connected. Not anymore. There is no one person that looks at any one of these big applications holistically. People look at parts of them. People are responsible for parts of them. So if you want to manage them intelligently, you need to have something working for you. You need to augment the human mind to manage this. So at VMware, we are looking at ML. We're investing in it for multiple different ways. We look at 3 real broad areas, though. The first is enabling our customers to provision, manage, and monitor their agile IT infrastructure. This is it. But also, this is more to support their ML requirements. So people building their own ML projects, we're looking at how can VMware both optimize our hardware management, optimize our software to support ML requirements. At the same time, we're looking to incorporate ML products, techniques, and services into what we do, so that to the point of this, we can help you manage and scale to an unbelievable level in terms of massively scalable applications and do predictive analytics at scale. And some of it is classic data analytics, and some of it's ML, but it's a lovely blended mix. And of course, we're using some ML techniques internally already at VMware to increase our own operational efficiency. We're actually using ML to look at our HR processes, for example. We're using ML to look at physical processes. We're using it to look at operational processes, not just IT. We'll also have various, as I'm talking about now, research projects and collaborative work we're doing with academic teams to drive the industry generally forward in the world of ML. So there's a lot of stuff going on in ML. Specifically where we're doing stuff on some products, we have ML in an awful lot of products. Frank and Duncan will get really excited because vSAN's on screen in a second. But yeah, vSAN was one of the first products to build analytics features on top of telemetry data, okay, to deliver these operational value, but also we're building it into VRO, building it into vRealize Log Insight. I mean, Log Insight is that in its essence. Wavefront, which if you've not looked at, please look at it, because I promise you, you'll be knowing more, you'll be hearing a lot more about Wavefront over the next 2 or 3 years from VMware, I can tell you that. Workspace ONE Intelligence, some of the stuff you've seen us demonstrate recently. App Defense, and now the acquisition of Carbon Black. There's an awful lot of ML that goes on in the Carbon Black cloud itself in terms of what they're doing on threat analytics, but then what we're doing on the agents with App Defense in terms of analyzing workloads and working out how they normally do things. And of course, our own support team use it in VMware Skyline. If you're a larger customer and you've not used or played with Skyline, please have a look at it. It's phenomenal in terms of understanding and assessing and giving you the hints and tips on what you should be doing to keep your VMware environment and your application platforms environment running at its optimal. So there's another project, which I'm still calling Project Magna. We've tried to call it 5 different other names, but it keeps coming back to being called Project Magna internally. And I don't know what we're going to call it when it's launched because it's still playing around. But what Project Magna realistically is looking at is holistically looking at the whole application stack and understanding how we can optimize that, and using ML to optimize the application stack. And there's some really funky stuff that's gone on here, okay? I don't know what's happened to the font on this. I think it's because it's come over to the Windows world. But basically, if you start to apply ML to tuning distributed systems and give it access to lots of different knobs, it twiddles knobs in ways that humans have never twiddled knobs before, okay? And there's some really cool things that have happened in lab testing with this. One of them was on one of our products where we have a specialist team that works in performance tuning that typically is in what we call marginal gains. You know, you apply them to a system and they'll get you, 5%, 8% performance improvement by twiddling this knob and doing that. We applied Magna to it and it got a 67% performance in gain, which is kind of like, well, hang on a second, what? How'd you do that? And that's because it's basically Doctor Strange, okay? It can model and see 14 million different possible futures and find the best one. And that's essentially a really good way of what we're doing here, not brute forcing it, but applying ML and then modeling it to do that. What it did on one of the tests, which is really, really odd if there's networking people in the room, it was adjusting the frame size for a particular application on a per packet basis. Now, you go to your network team and tell them that you'd like to adjust the NTU for some packets on a per packet basis for one particular application. They'd look at you and just go, oh, free drugs, where's that? But because you can, because it's all in software, it was doing it. Never thought of doing that, but it kind of was one of the 14 million Doctor Strange futures it envisaged. This was one of the ones that did it. So there's some really cool, funky stuff happening as we look at complete holistic systems and we look at them from an ML bent. So, when we look at this VMware vision that we paint for people, this continual slide we put up all the time of allowing you to run any application on any cloud and any device. I suppose what we're really looking at now with all this ML and AI research that we're doing, along with all those other things you saw us do, is understand how to enable you to do that at scale, in more ways than you've ever done it before, opening up more possibilities than you've ever thought of, and inventing new ways of doing things that you'd not thought of before. So you're going to go on a journey, and we call that journey Run All the Things. And again, the transition to Windows has screwed up all the fonts here. But you're going on this application evolution, okay? The first one you've got is you're going to be running your traditional monolithic applications. I think I'm reading off the screen, all right? And they're going to run on IaaS. You're going to use stuff like VRA for that. You might want to actually maybe play about with OpenStack if you're particularly masochistic, but it's there, okay? Mainly OpenStack. We have VIO, which is the VMware Integrated OpenStack, which is actually mainly used by telcos. But then you're going to start playing with hybrid and microservice applications. And for that, you're going to start wanting to play with IaaS-based containers. And then someone's going to come and talk to you about cloud-native apps and services and all this new sexy stuff you're going to have to do. So you're going to have to start playing with containers as a service. And yes, I get to mention Kubernetes for the second time. I say it's cool. I've done an entire keynote at VMUG and only said that word twice. It's cool, isn't it? All right? And then you're going to maybe want to start playing with PaaS, something like Cloud Foundry, or even start entering into the world of functions as a service. This future for you includes all of these. And it's not going to be a continuum of moving one to the next. There will be points, as you well know, where you're going to run all of this as well. You're going to be required to run all of this. And many people are going to come up and tell you they've got fantastic answers for individual bits of this picture. But what we're working on here at VMware is making sure that we have a fantastic platform that has the answers for all of the bits of this picture. And that's the SDDC. And that SDDC, we're making sure that we have answers for where you want to run it, to being in any cloud, in your data centers, and on the smallest devices you can imagine, giving you the true flexibility to run all the things. Opening up the possibilities that when someone does say they want to play with one of these things, you can go, yes, there it is, let's go. So the only thing you've now got to think about as we go forward into the future, and we go forward into the break now, is how are you going to augment yourself, your business, and your customers, or citizens, or clients, as you go forward? What technologies, what ML, AI are you going to use to change the way that you do things, not to replace, but to augment, improve, and optimize in ways you'd possibly not thought of before? And with that, time for a break. Thanks very much.